Okay, everyone, here we are in section 7-2. In this section, we are looking at graphing exponential functions and how we can transform them using changes to the equations. This is very similar to what we've done many times already this year, even though it might not look like it. So let's look at the first equation that you see here, y equals 3 to the x. This is Desmos, by the way. And you should do this on your own. You should go to Desmos and check out different sorts of equations. So y equals 3 to the x. We see when x is 0, we have 1 because anything to the 0 power is 1. And then we have an exponential growth. Okay, we're multiplying by 3, so when we get to 1, which is right here, we're up to 3. And then when we get to 2, we jump up to 9, and so on. And going back the other way, when x is -1, we have 1/3. And when x is -2, we have 1/9. And then it gets closer and closer to the y-axis. This is called the asymptote, right? But it never touches. All right, now what happens when we multiply this equation by 2? I want you to think about that for a second. What do you think is going to happen? And then let's actually see what happens. So if we multiply by 2, every y value gets multiplied by 2. So whereas we had the point 0,1, we now have the point 0,2, right? So actually, let me go here. So now we have the point 0,2. All right, the point that was 1,3 is now 1,6. Okay, you see that point? Get right on it, 1,6, and so on. Going the other way, okay, we had 1/3, and now we have 2/3. So this is 1, so 2/3 right there. And so on. Again, gets closer and closer to the y-axis, never actually gets there. So everything got stretched by a factor of 2. Everything got doubled. So the 2 has an effect of stretching. All right, now, what if we do this? This is really weird looking. We put a -4 inside the parentheses. Back when we were learning about quadratics, we learned that if you put a 4 inside the parentheses, it moved everything to the right. So let's see if that's what's going to happen here. So that would predict that. Let's go back. I'm going to turn this one off. Back to this graph. This point right here, moving to the right, would go over to here. Okay? And then this point, when x is 2, y is 9, that would move all the way over to, so now we're at 2, so 2 plus 4 is 6. So that would move over here. So let's turn this on and see if we're right. Oops, I hit the wrong one. Turn that off. There we go. Okay, and you can see that in fact this point here moved over by 4. This point here moved over by 4. This point here moved over by 4. So -4 to the right. Okay? +4 would be a move to the left. All right. Now, how about this one? 3 to the x plus 1. We learned before that's a vertical translation. Just moves the graph up by 1. So we should see the same graph just moved up by 1 unit. Let's see if that's correct. And there we go. So now you can see the asymptote actually moved up by 1. This number right here is our asymptote. Okay? So 3 to the x plus 1. And now we put it all together. So now in this last equation, we have times 2 minus 4 plus 1. So what should that give us? It should give us a vertical stretch of 2, a move to the right of 4, and up 1. So let's see. Okay, so let's see here. Let's take this point, for example, on the red graph. The point 0,1 gets multiplied by 2, up 2, goes to the right by 4, over 4, and up 1. There we go, right there. So this point right here becomes that point right there. Okay, you see how this works? Now I want to do one more thing, and that is to put a negative number in the front. So let's go here and say y equals -2 times x times 3 to the x. So anybody have any guesses? Whoops, I typed that wrong. -2 times 3 to the x. Anybody have any guesses as to what that's going to look like? What's the negative going to do? Oh, turns it upside down. Okay, so it takes this graph here, which is a green graph, and just flips it over the x-axis, turns it upside down. And that is in a nutshell, is how we transform exponential functions.